Hello there, welcome to another teaching section. Today we'll be talking about magnetism. So, for you to understand this course, we're going through some terminologies. So, the first on the list is what we call magnetism, which is the main deal here. So, magnetism is a force of attraction or repulsion that acts between certain materials, such as iron, nickel, due to the motion of electric charges. So, here it's just the force that will determine whether magnetic materials, such as iron, nickel, will attract to each other or repel from each other. So the second on the list is what we call magnet. So this is what a bar magnet looks like. So it's just a material that produces a magnetic field and exerts a force on other magnetic materials, attracting or repelling them. So here it's just a material that has some force around it that will either attract other materials to it or repel them from it. Do you get it? So it has some force that will either attract itself to other materials or repel other materials from attracting to it. So the third on the list is what we call magnetic field. So it's an invincible area around the magnet where magnetic force is felt. So around this magnet there is an area, the area around it. So uh, you can't see with your eyes, that's why it's invincible. So the area around this, not the lines though, but the area around it, it has some sort of force that will help to attract or repel other magnetic materials. So the direction and strength of that magnetic field is what is represented by these magnetic field lines. So these lines represent the magnetic field. The magnetic field lines represent the direction of that magnetic field I was talking about, or the area around it. So this magnetic field lines helps to show it more, makes it more visible. Do you get it? So next is types of magnets. So our first on the list is permanent magnet. So this does not make use of the use of electricity. So here it's permanent. It magnetizes other magnets. So here it's stable. It always has a magnetic field. It doesn't need the help of other magnets to be magnetized. It rather magnetizes other magnets. So an example is a bar magnet. Second on the list is a temporary magnet. So here a temporary magnet is made when a magnet comes near another magnet which is very strong. So when that magnet is removed, that magnetism is lost. That's how it is. So the temporary magnet is made when a strong magnet is brought closer to it. So when that strong magnet is removed, it's no longer magnetized. So our next one is electromagnet. So here these are created by electricity. So here we just wrap a coil or a wire coil or maybe a solenoid around it. So here, and electricity is being passed through it, and when such is done it is magnetized. So when electric charges flow through a wire coil around a metal core, it becomes magnetic. So here it makes use of electricity. An example is MRI machines, electric bells, cranes in junkyards. So our next is the law of magnetism, which says like pulls repel and unlike pulls attract. So an example, let's take these two bar magnets. So this is this is the north pole and this is the south pole. This is the north pole and this is the south pole. So when this north pole you see here, and this north pole you see, this north pole and this north pole you see here, both of them, when they come close to each other, since they are like poles, they'll repel. But if this south pole come close to this north pole, they will attract. Why? Because they are unlike, they are different, they are different poles. So this and this will what, will attract, but this north pole and this north pole will repel. This south pole and this south pole will repel. So that's all you need to know about law of magnetism. So our next is what we call ferromagnetic materials. So they are materials that are strongly attracted to magnets. So an example is iron, nickel, cobalt, etc. Next on the list is what we call magnetic non-magnetic materials. So they are not attracted to any magnet. So an example is plastic, wood, rubber. Wood, plastic, rubber can never be attracted to a magnet. So next term is what we call demagnetization. So the process of removing a material's magnetic properties what we call demagnetization. So when you take a temporary magnet, for example, when a strong magnet is removed, it is demagnetized because it has lost its magnetic property. You get it? So the process of you making the temporary magnet magnetic is what we call magnetization. So when you are making a magnetic material magnetic, is what we call magnetization. So last then, um, let's talk about the Earth as a magnet. So you've wondered why always you take a compass and it will be pointing towards the north. That means it shows it's an evidence that the Earth is a magnet on its own, because something is attracting it always to the North Pole. So it shows it's a magnet on its own. So the Earth also behaves as a what? A huge magnet. So there is some sort of magnetic field around the Earth. It's invincible though, but it plays a very vital role in our daily lives, such as the compass I talked about. Let's talk about the uses of a magnet. So they are used in in fridges of doors. They are used in speakers and headphones, microphones, electric motor generators, MRI machines in hospitals, junkyards to lift heavy metals, in magnetic compasses, and a whole lot. So you can keep all these uses. These are all the uses of a magnet. So thanks for watching. You can subscribe, like, and comment the next tutoring section we want us to do. Bye.